In this lesson, we will learn how Active Directory topologies are generated within a site. First, we will learn about the types of replication topologies that can be generated in a single site. Then, we will learn how connection objects are created within a site that has single domain and a site that has multiple domains. After that, we will learn about the expanded ring topologies, and finally, we sum up our lesson with the keynotes. As you know, to replicate Active Directory partitions, a connection object topologies must be created among all domain controllers in an AD forest. Within a site, connection objects are created in such a way to allow the DCs to form any of the following ring topologies. The first ring is to replicate schema and configuration partitions. The second ring is to replicate a domain partition. And each application directory partition will require a ring. And finally, only one ring is required to replicate global catalog read-only partial domain directory partitions. As you can see, connection objects can be shared among these topologies, and within a site, the connection object topologies is the combination of these ring topologies. Let's get into the detail. As we know, when the first domain controller CPVDC01 is promoted in the root domain it-liveskills.local, it is assigned with all 5 FSMO roles. It automatically assumes the global catalog server role. It is put in the default first site name, and the KCCs on CPVDC01 elects itself as the intersite topologies generator and bridgehead server. Let's promote CPVDC02 to a domain controller in the same domain it-liveskills.local and put it in the same site default first site name. While being promoted to domain controller, the KCCs on CPVDC02 checks the site configuration in the configuration partition and finds CPVDC02 is in the same site with CPVDC01. The KCCs on CPVDC02 creates the inbound connection objects from CPVDC01 to CPVDC02 to allow CPVDC01 to replicate all 4 partitions to CPVDC02. CPVDC02 is not configured as a global catalog server, so it does not attempt to replicate any global catalog data. The KCC on CPVDC01 also checks the size configuration in the configuration partition and finds CPVDC02 is in its size. The KCCs on CPVDC01 then creates an inbound connection from CPVDC02 to CPVDC01 and replicates any changes from CPVDC02. The site is then renamed to Chicago and it is updated in the site configuration as Chicago site. While promoting a new DC, CPVDC03 to the same site, Chicago, and in the same domain it-liveskills.local, the KCCs on CPVDC03 finds in the site configuration that CPVDC01 and CPVDC02 are in Chicago site. However, the KCCs on CPVDC03 chooses to create the inbound connection from CPVDC01 to CPVDC03 and start replicating the partitions. The KCCs on CPVDC01 also detects CPVDC03 in Chicago site and creates the inbound connection from CPVDC03 to CPVDC01. The KCCs on CPVDC02 also detects CPVDC03 in Chicago site and creates the inbound connection from CPVDC03 to CPVDC02. After being synchronized with CPVDC01, the KCCs on CPVDC03 then creates the inbound connection from CPVDC02 to CPVDC03. The three servers are now replicating to each other in a ring topology. Similarly, while promoting CPVDC04 to a domain controller, the KCCs on CPVDC02 and CPVDC03 and CPVDC04 create inbound connections to each other and start synchronizing. The KCCs on CPVDC03 and CPVDC02 drop the connection objects to each other since they find they can get updates via CPVDC04. The four servers are now replicating to each other in a ring topology. When we install a new DC CPVDC11 in the child domain hq.itivlifeskills.local in Chicago site, CPVDC11 will be assigned all three FSMOs roles and global catalog role in the child domain hq.itivlifeskills.local. Two pairs of connection objects are created, one between CPVDC02 and CPVDC11, and the other between CPVDC04 and CPVDC11. When we install a new DC HPVDC01 in the child domain hq.itivlifeskills.local in the same Chicago site, two pairs of connection objects are created, one between HPVDC01 and CPVDC11, the other between CPVDC04 and HPVDC01. The pair of connection objects between CPVDC04 and CPVDC11 get dropped as they find the replication path via the HPVDC01. When we install a new DC OPVDC01 in the child domain hq.itivlifeskills.local in the same Chicago site, a pair of connection objects are created between OPVDC01 and CPVDC11. Another pair of connection objects are created between HPVDC01 and OPVDC01. As soon as connection objects are created, the following ring topologies are generated in Chicago site in the AD forest. The light blue ring is used to replicate schema and configuration partition, and an additional identical ring is created to replicate application partition with forest-wide scope. The dark blue ring is used to replicate domain partition of the domain itivlifeskills.local, and an identical ring is created for all application partitions with domain-wide scope for the domain IT life skills.local. The valid ring is used to replicate domain partition of the domain hq.itlifeskills.local, and an additional identical ring is created to replicate all application partitions with the domain-wide scope for the domain hq.itlifeskills.local. The yellow connection is created between CPVDC01 and CPVDC11 to replicate global catalog data between the two domains. Let's learn about expanded ring topologies. As you know, KCCs create inbound connection objects for all domain controllers within a site in a ring topology if it takes 3 hops for an update from a DC to travel to all domain controllers in the ring. Therefore, this topology with no other adjustments accommodates only 7 servers. Beyond this number, optimizing connections are created at random DCs. In this size, there are 8 domain controllers, and the connection objects have been created among all the DCs in the ring topologies. Now, when a new data generated from CPVDC06, it will be sent out in both directions. As you can see, when the data travel 3 hops in the green ring, then CPVDC07, CPVDC08, and CPVDC01 get updated. And when the data travel 3 hops in the red rings, then CPVDC05, CPVDC04, and CPVDC03 get updated. So in this topology, it requires 4 hops for a data to travel from CPVDC06 to CPVDC02, which means it requires additional optimizing connections. So in this size, to allow CPVDC06 to send updates to all DCs in the ring within 3 hops, a pair of optimizing connections is created. And here is how the data travels. To allow a DC to send updates to all DCs in the ring within 3 hops, an additional pair of optimizing connections is needed. Please note that this is one of possible options. The optimizing connections are created at random DCs. This is the end of this lesson. Let's read the keynotes.